न्यूक्लियोटाइड्स और लिपिड्स का बात है. Nucleotides are the small complex molecules which take part in the information transfer system because they are components of nucleic acid and nucleoids. Nucleotides will polymerize to form the nucleic acid. Okay, because they are components of this. Also take part in the energy transfer system as ATP is a nucleotide, and nucleotides are again of two types: nucleoside and nucleotide. Nucleoside are nitrogenous base, have nitrogenous base and pentose sugar. Nucleotide have only nitrogenous base, pentose sugar as well as phosphate. Now since nucleoside no phosphate, they won't yield H3PO4, that is a phosphoric acid on hydrolysis. Now nucleotides are again of two types: ribonucleic and deoxyribonucleic. Ribonucleic on polymerization forms the RNA, we know that, and deoxyribonucleic forms DNA. Okay, that is also known. What is nucleotide? Nucleotide is the third option because it is not a polymer. Okay, it is simply nucleotide. Now nucleotides are formed by the polymerization and not formed by the polymerization, therefore second option won't be correct. Now common sense. Now nucleotides have heterocyclic rings. Okay, now next thing, that the nitrogen bases that constitute this are again of two types: pyrimidine and purine. Pyrimidine are single ring, purine are double ring. Pyrimidine examples are thymine, ura, ura, uracil, okay, and cytosine. Now purine is again of examples are adenine and guanine. DNA is having deoxyribose and RNA is having ribose. DNA has adenine and guanine purines, both the purines, and also the RNA also has both the purines. Now pyrimidine as present in the DNA is only cytosine and thymine, and the RNA of the pyrimidine that is present is cytosine and uracil. Now pyrimidines are three: uracil, thymine, cytosine. These three are the structures. Now all the pyrimidines, nitrogen is present at the position number 1 and 3 within the ring. Purines, okay, purines are two: adenine and guanine. These are the structures. Okay, both the purines, nitrogen is present in the position 1, 3, 7 and 9. Rotland. Now very important this page. We you see here adenine plus ribose sugar is forms the adenosine, and adenosine with phosphate mixed with phosphate gives adenosine monophosphate, that is adenalic acid. And similarly guanine and ribose give guanosine, and when phosphate GMP, then cytosine plus ribose cytidine. And thymine, okay, thymine with mixed with only and only deoxyribose. This is to be learned, not ribose. Rest 4 can be mixed with ribose and deoxyribose. Thymine is the only exception. Now nitrogen base is always attached to the carbon 1 of pentose sugar. Pentose sugar is just carbohydrate, nothing else. Now that is ribose or deoxyribose. Now the phosphate that is always attached to the carbon 5 of the pentose. Okay, and OH group of C5 of pentose reacts with the PO4 phosphate group to form phosphoester bond. Now to know what this is saying, see here. Here is simply ribose, and here is we have adenosine, and then it combine, and then it is forming adenine, and adenine and phosphate. Okay, then both the combine, then it will form adenosine monophosphate. Okay, and the bond, this is ester bond, and here the bond is, that is 1,9 glycosidic bond, because see numeric starts from here 1 2 3 4 5 6, then 7, then 8, then 9, and then ninth nitrogen, and here OH and here NO. Okay, O and OH liberate. Now H2O gets removed. Similarly here there was CH2OH. It is simply ribose, nothing else, and nothing complex. CH2OH, and here we know that phosphate is OH, so OH from here and H from here remove, and C double O, C O O. This is ester, phospho ester to be more precise. Now this is again uridine. Okay, why? Because here we have uracil instead of adenosine, and here we have simply the simple ribosome. Now nucleotides of nitrogenous base polymerize to form the nucleic acids, that is DNA and RNA. But some nucleotides of vitamins, okay, they act as coenzymes of oxidation reactions. Now example of this is thymine. Thymine as a as a thymine Thymine as a pyrimidine is present in the DNA, but thymine as a nucleotide, because pyrimidine is what? Pyrimidine is in nitrogen base. It is not actually the not a nucleotide, and in the nucleotide of the uh, thymine is not in DNA, since it is a vitamin, so it won't be present in DNA. Now it will accept the protons and electrons is released during the oxidation and will be reduced. Simple thing. Now vitamin B3 and vitamin B2. Vitamin B3 also known as nicotinamide. Now its nucleotide is nicotinamide adenine dinucleotide. Since two dinucleotides, so two phosphates are present. Now components are nicotinamide, then ribose, then PO4, then PO4, then ribose, then adenine. In the same manner as said. Now, nicotin ribose and PO4 is one nucleotide, and then PO4 ribose adenine is second nucleotide. Similarly, NADP will have one PO4 extra in between the two PO4s. Now B2, that is riboflavin, it forms the nucleotide FMN, that is riboflavin monophosphate. Uh, it will have one nucleotide, okay, since it is mono and monophosphate, so one phosphate. Riboflavin and PO4 is structure. Similarly, riboflavin adenine dinucleotide will have riboflavin PO4, and then the adenine dinucleotide will be here. That is PO4 ribose and adenine. PO4 ribose and adenine. Okay. Now, which of these them is absent in DNA? Adenine, guanine, thymine, and cytosine. Now, it answer is thymine because it is vitamin B1, and it is not present um, as a nucleotide. Okay, it is just a nitrogen base in the DNA, not as a nucleotide in the DNA, and it is a vitamin B. And we just knew that vitamin B forms the coenzymes. Now, deficiency of vitamin B1, that is thymine, leads to beriberi, and literal meaning of berry is I can't, and the meaning of this disease is I can't because the body is paralyzed. ATP is currency of cell, and all the is having nucleotides having more than one phosphate are called high energy molecules. ATP is also high energy molecules in triphosphate, triphosphate. It was discovered by Lohmann and Fritz Lippmann. Lohmann is who discovered it, and Lippmann is the father of ATP cycle. ATP is the immediate source of energy for the body. Now this is the another structure. Now this is ribose, and it is simply nothing but adenosine. Okay, adenine. This is this is adenine. Now this is adenine and this is ribose, and this is the phosphate. Simply instead of last time there was here, yes, here there was adenine, and here now instead of adenine there is mm, no, it is the same thing, same adenine, nothing else, ekdam same hai, and just the difference is one phosphate has been combined. Now it is also called 5-AMP because the fifth carbon of ribose is made the phosphoester bond, so it is 5 dash. Now C AMP is cyclic, stands for cyclic AMP. It acts as a second messenger of hormones. Now CAMP is actually 3 dash 5 dash AMP. Nothing changed, but this OH will mix with the third carbon. Okay, C1, C2, C3, C4, and C5. The third carbon here OH and OH a bond another phosphoester bond will be formed. Now here we have ATP, here is ribose, here is adenine, and here is one phosphate, two second phosphate, and third phosphate. Now ATP when hydrolyzed by the ATPase enzyme, that is adenosine triphosphatase, and it will form ADP, and 8.9 kilocalorie will be released. Similarly, ADP on AMP will release 6.3. Now, if ATP is directly or finally change into AMP, then how much kilocalorie will be the addition of these two, that is 15.4 kilocalorie. Glycosidic bonds are of two types: O-glycosidic bond and glycosidic bond. O-glycosidic is what we have been learned in the carbohydrate. Okay, it is sugar between, and it is between sugar and either NH2 or NH. Okay, that is CNC. Now lipids are include heterogeneous group of chemical like oil, butter, ghee, wax, cholesterol, plant pigments, carotenoids, lycopene. Lycopene is the red pigment in the tomatoes, land in the body. Now fatty acids are made up of long hydrocarbon chain with the hydroxylic group at the end. Example: palmitic acid. It has C15H31 and COOH formula, where R is a long hydrocarbon chain, and R can be CH3, C2H5, or higher group of CH2, combination of any three. Now the number of carbohydrates in the R group, that is the hydrocarbon group, is from 1 to 19, excluding the carbon present in the carboxylic group. Now moving further ahead, essential body fatty acids are those acids which can be synthesized in our body but have to be obtained. There are only three of these, and all the three are unsaturated. Examples are linoleic and linolenic, and then arachidonic. Linoleic is having two double bonds. Linolenic has having three double bonds. Arachidonic has four double bonds. Linoleic and linolenic are derivatives of C18, and arachidonic has derivatives of C20. Most essential of all the essential fatty acids, that is the very important, is linoleic, that is the uh, first one. Now linoleic is absent in coconut oil. Okay, very important. If there is deficiency of an essential fatty acids, it will cause a disease, pherenoderma, or follicular hyperkeratosis, drying of skin. Now to avoid this, since baby drink milk, so small children prone to follicular hyperkeratosis, drying of skin, so they are all massaged daily. Now next, fatty acids are saturated and unsaturated. Saturated are those which have higher melting points. General formula is CnH2 and O2. And the richest source of energy in our body is fats, but the principal, that is main source of energy which is obtained through, is carbohydrates. Now why? Because here only two. Now carbohydrate formula, we know that CnH2 and ON. Now it would be, if you see per molecule oxygen present, it would be very less. Only two of them are here oxygen, and the rest may be n, and maybe 16, 18, and lot, but oxygen is very limited. So since less oxygen is there, so less oxidation would occur, and no energy would be taken out from the saturated fatty acids. So for every 1 liter of oxygen phase, carbohydrates yield more energy. That is the reason. Now take n barabar 16, then the fatty acid will be C16H32O2. Simply put the formula. Now C15H31 COOH. If you remove COOH, then this is palmitic fatty acid, the most common saturated fatty acid in our body. Okay, it has 16 carbon atoms including the carboxylic atom, and 15 if you exclude the carbon in the carboxylic group, that is this carbon. Now it can also represent as CH3, then CH2 whole 14, then COOH. This is just the representation of that, what was in the start of lipids, that they can be represented the CH3, C2H5, and higher bonds of CH2. Now if n barabar 18, then it is C17H35 COOH, steric fatty acid, learned in chemistry in types. Now n barabar 20, it will form C20H40O2. It is arachidic fatty acid. All three are saturated. Now unsaturated fatty acids, these are more reactive because of the double bonds. They have double bond and their melting point is low. Now General formula is CnH2n minus 2x O2, where n is the number of C atoms, simple, and x here is the number of the double bonds that it contains. Because of the double bond, okay, these double bonds may be 1 2 3 4, okay, any of them. Now if n barabar 18, that is derivative of stearic acid, and n barabar 18 was here also, and if x barabar is 1, so it will form C18H34O2, oleic acid it is. It has only one double bond. It is most common unsaturated acid in plants and animals, most common in plants and animals. Now it is represented as here you see CH1, and then there's one of CH, and there is double bond. Okay, only one double bond, so therefore only X would be 1, so 2 would be subtracted from the H, and since 8 double is 36 and 36 minus 2 is 34. Now hydrogenation of oil into vanaspati ghee, unsaturated fatty acids in the oil are converted into saturated fatty acids by forcing hydrogen in the presence of nickel. Learned in class 10. Drawback of hydrogenation of oil into the vanaspati ghee is that the unsaturated fatty acids are get reduced. Now, for example, if hydrogen of groundnut oil is to vanaspati ghee is done, then essential fatty acids are reduced from 28% to 2%, which is very bad for health. Now if to n barabar 18 and x barabar 2, then it is linoleic acid. Then if n barabar 18 and x barabar 3, it is linolenic acid. And if n barabar 18 and x barabar 4, then it is arachidonic acid. Okay, formula is are very easy, just need to be learned. Okay, since common says 32 30 32, very easy, not very tough. And then uh, there, the arachidonic fatty acid has 20 carbon atoms, including the carboxylic acid. You see here, hmm? And 19 carbon atoms, including the carboxylic carbon. It is found by the arachidonic. Okay. Now next thing, classification of lipid. Three types: simple lipid, conjugated lipids, derived lipids. Simple lipids are glycerol plus fatty acid or alcohol plus fatty acid. These are actually oil, fat, and wax. No additional groups are present. Okay, glycerol is also a simple lipid. It is a hydroxypropane. Now conjugated lipids are the compounds lipids. They are additional groups attached in them, like glycolipids and phospholipids. Now derived lipids are sterol, cholesterol, terpenes, essential oils. Now simple lipids are the fats are esters of fatty acid with glycerol. Fatty acid and glycerol, okay, ester is fat. Now one molecule of fat is made up of one molecule of glycerol and three molecules of fatty acid. If into the glycerol in only one fatty acid is attached, then it is called monoglyceride fatty acid. Two, then diglyceride, three, then triglyceride fatty. Now triglyceride fat example is here is the glyceride, and then H2, and then palmitic acid, and stearic acid, three are joined to them. Now it is actually a mixed fat also. Now here there is ester bond, okay, since here is a fat, here is a the here is the glycerol. Now three fats attached on the three bonds forming the ester bonds. Okay, now this, the name of this is dipalmitosteyrin fat. The name of this is, it is a mixed fat. Now the common formula is R1 R2 R3, which could be actually any acids. Now fat molecules never polymerize, so they are biomicromolecules. Now AIVases are also called as esterases, because they break down the ester bonds. Now triglyceride, when acted upon by lipase, are forming diglyceride and fatty acid. Then again monoacid and fatty acid. Monoacid and fatty acid acted upon lipase forms glycerol and fatty acid. Now fats are again of two types: pure and mixed. Pure is simply the three, all the three having the same acid, like tripalmite, trisaccharine, tristearic, many, and then mix is just this. Okay, mixture of more than one acid. They have palmic acid two, and then one stearic. So it is two acids actually, two types of acids. Okay, so two fats, no mixed acid, and then fats are again of two types: soft and hard. Hard having the long hydrocarbon chain. Okay, the hydrocarbon chain is very long here. Now example is ghee. Soft is butter example. Now it contains short hydrocarbon chain, like that is butter is having butyric acid, that is this CH3 CH2 whole 2 COOH. Oils are made up of one molecules of glycerol and 1 to 3. Okay, maybe 1, maybe 2, maybe 3. Okay, molecules of fatty acid, but most of the fatty acids here are unsaturated. They are not saturated, not all are saturated, mostly they are unsaturated. Example, gingerly oil, that is teal, sesame oil. Now it is liquid at room temperature oil because it has low melting point, common sense. Now oils are more reactive because of double bond. If we keep oil outside, they have double bond, so they are more reactive. If we keep outside, then they may react with oxygen or the other chemicals present in the atmosphere and start solidifying. And this such a oils are called drying oil. Now oils contain fatty acids which can be either MUFA or PUFA. Fatty acids can be MUFA, PUFA as well. MUFA are the monosaturated, unsaturated fatty acids. PUFA are the polyunsaturated fatty acids. MUFA is having only one double bond. PUFA is having more than one double bond. So example of MUFA is oleic acid, and then PUFA is having, okay, linoleic and linolenic and arachidonic fatty acids, that was learned in earlier. Unsaturated these three, and this is also unsaturated. Now oils containing PUFA are better for the heart patient because they have low blood cholesterol, these three, because having more than one double bond. Now example are gingerly oil, sunflower oil, safflower oil, and corn oil. Okay, these four are good oils. Now it is because PUFA, that is this, is having HDL, that is high density lipoproteins, which carry the cholesterol to the liver where it is processed. Now HDL increases the concentration in our body when a person does exercise. Now sedentary worker, that is stationary worker, is more prone to heart attack because of less presence of HDL. Now LDL is the low density protein. Is It is bad for heart patient. It is richest in cholesterol. It makes the cholesterol deposited in the artery, and this process of deposition of artery into the inner so cholesterol into the inner wall of artery is called arteriosclerosis. Now wax are simply lipids, nothing else. They are esters of fatty acid with the long chain monohydric alcohol. Okay, oil was what? Glycosid. Oil was what? Okay, it was the oil was what? It was the actually the ester. It was the glycerol and the uh, few molecules of fatty acids. Now wax, it is simply glycerol, fatty acid, and monohydric alcohol. And instead of glycerol, here is alcohol. Now examples of alcohol are cetyl, and mericyl. Mericyl is this formula C30H61OH, OH since it is alcohol. Now B-wax, number one wax, it is secreted by the abdominal glands of Volcker B. It is made up of palmitic fatty acid and methyl alcohol. B-wax is made up of hexo, hexo, hexacosyl palmitate. Now lanolin is the wool fat. It is a wax. It is secreted by the cutaneous glands of the mammals. It forms the waterproofing coating of the fur. Cutin is a plant wax. Suberin is present in the cell wall of the coxial. Cerumen is earwax. Cerumen is earwax that is secreted by the ceruminous glands of our ear, and it is modified sudorific glands. Now, actually, earwax, what secretion of modified sudorific gland, that is secretion of sweat gland. Okay, earwax is a secretion of just a little bit modified sweat gland. So that gland is ceruminous gland of the ear. Now spermaceti oil, and it is present from the head, obtained from the head of sperm whale, that is Pfizer, and it is very good quality lubricant and used in cosmetics, and it is cetyl palmitate, and the B wax is hexacosyl palmitate. Now next thing, here we have the last one is wax D. Okay, so spermaceti oil is a liquid paraffin wax, nothing else. Wax D is forms the coating around the cell walls of the tuberculosis and leprosy bacteria causing. Okay, and then it is responsible for the pathogenicity. That is all about it.